Yeah. So what we have done yet is we have learned the differentiation of, integration of many functions, right? We know how to use integration. We can find out the area bounded by two curves using integration. And this is the another use where what we are doing is, so we have a lot of equations which are differential, first of all. Now, what are differential equations? Anything that involves something like derivative part of some function. So dy by dx or d2y by dx square, or when we write differentiation of one function with respect to another function, in that case, there's a term derivative dy by dx produced. And if we use that term in any equation, so what is it? What is an equation? Equation is something which consists two parts which are related by an equality, right? Which we call as right hand side and left hand side. So differential equation will be something that uses these derivative functions in the form of any equation. So let's say this is an equation which includes this derivative part. So this can simply be termed as a differential equation. Now there are many types of differential equations, but before that, anything that involves a derivative will be known as differential equation, right? So now when do we have such equations? First question is this. So there are many sectors in which we have the equation in terms of derivatives, like heat. Heat equations are generally differential equations only. Anything related to thermodynamics. So thermodynamics is a whole new section, right, in which there are equations which will be differential equations. So you'll have to solve differential equations. So sometimes you may not know the function, but you know the change of change in the function with respect to any other function, right? Dy by dx derivative. So you know the change, but you don't know exactly the function, how this thing is working. In these cases, you will use differential equations to solve, right? So now, how many types of differential equations do we have? They can be typed into two possible areas. Basically, there are two different dividation of differential equations. First is on the basis of degree. And second, on the basis of order. So there are many different kind of differential equations. Like you can also write d2y by dx square plus y into dy by dx plus k is equals to 0. Right? This is also a differential equation. But here you can see that there is a second order derivative that is used. Right? Second order derivative means two times this function has been differentiated twice with respect to x. Hence we are using second order derivative. So what is an order? Order is that how many times have you differentiated your function, right? And just a minute, let Hadia join as well. Please just give me a minute. Hadia, am I audible?
Yes, sir.
Okay. So we have started with the last chapter of integral calculus, which is differential equations. I was just explaining what is the basic differential, what a basic differential equation looks like. This is basically an equation which includes derivatives, right? I mean, we know what are the representation of derivatives are. So it can be represented either as dy by dx, right? Or it can be represented as y1, right? Sometimes it may be represented by y1 or sometimes by y dash, right? So these are the notations which we can use for derivative. So this basically means first order derivative, that we have differentiated our function once, right? It can also be like d2y by dx square plus y into dy by dx plus k. This is some constant, right? These kind of equations which include your derivative directly are known as differential equations, right? Now, differential equation, there are two important things related to differential equation. First they can be typed as degree, on the basis of degree, and second important thing is order, right? So these two are important things. Let me underline them: degree and order. So what is the degree of a differential equation? What is an order of the differential equation? That are the two things that we should focus on when we first see differential equation, right? Now, what are the meaning of order and degree? It is that whatever your equation is, how many times you have differentiated your function with respect to x, right? Or with respect to some other function. So before this, let's understand two basic things. One is independent variable and other is dependent variable. So what is an independent variable? Like, let's say we have an equation y is equals to x square plus 2, right? Now you can put any value of x. You can use any value from minus infinity up to plus infinity for your function, right? If you put x is equals to -2, you get answer y is equals to 6, right? If you get x is equals to 100, you get y is equals to 10,002, right? So you'll get any answer for y. I mean, you can put any value of x and you can get a value of y. But see, you can put any value of x, but you can't put any value. You can't assume any value for y. Let's say you want to have, see, the range of y here is 2 to infinity, right? Because x square will always be greater than equal to 0. So this whole value will always be greater than equal to 2, right? And in this case, you can't have any value less than 2. So y is dependent on x. X can take any value, but y is restricted, right? Y has a range from 2 to infinity. So this x variable will be known as independent variable. So basically, anything that can assume value freely. And dependent is that depends on other variable. So y here can only take values from 0 to 2 to infinity, but x can take any value from minus infinity to plus infinity. So these are functions. Sorry, there will be a function when there is a function, there will be some independent and some dependent variables. In your course, it will always be one dependent variable and one independent variable. Y is generally seen as dependent variable. I'm not saying that this is a general, I mean, this is a rule, but mostly 99.5% cases, you will be having y as dependent variable, right? And x will be considered as independent variable. Now, what's the use of this in differential equation? Let's see, whenever you have this expression derivative dy by dx, so whatever is written in the numerator will always be dependent variable, and whatever is written in the denominator, that will always be an independent variable. So mostly this will be written as dy by dx, but sometimes it can also be written as dx by dy. Whenever there is dx by dy, the things will be same, the procedures will be same. We have to just interchange x and y. So in those cases, your equation could be x is equals to y square plus 2. See, now x is dependent and y is independent. We can choose to, I mean, we can choose any variable to be dependent or independent variable, but in most of the cases in your book, x will always be independent and y will be dependent, right? So what we are talking about here is on the basis of order. Order is something that how many times you have differentiated your dependent variable with respect to independent variable. This is important. How many times differentiation happen. Right? And degree is, see, the degree is, if your equation is polynomial, so we will use D for differential equation in the subsequent times, right? So if your D is polynomial, this polynomial is important. The highest power of order. So if your D is polynomial, the highest power of highest order derivative will be your degree. Right, let's understand these two things with an example. So let's say we have this equation. Yeah, right. We have these two equations, right? In which we want to understand the power and degree of the equation, right? Power and degree and order of the equation. So let's take first function first. So if we talk about order, we have only one derivative, which is dy by dx. So we have only differentiated dependent variable with respect to independent variable once. So the order is one, right? Now, if we take second equation, we have two derivatives. This is d2y by dx square and this is dy by dx. So clearly, we have second order derivative here. So its order is 2. Right? And its order is 1. Now, if we talk about degree, so degree is if your d is polynomial. No, so now, do you know, guys, what is a polynomial? I mean, we have learned, we have read about a lot. Maybe in 9th and 10th, we have polynomials. So do you guys remember what is a polynomial? Okay, is this equation a polynomial? Second equation, which I have written here.
Yes, sir.
Okay, and first, is first one a polynomial? No, you can give your opinion. I mean, that's no worries. What do you think about it? No, why, Jay?
So only one. I think there's only one derivative, and
Okay.
the order is 1.
Okay, and degree is
Degree is only 1.
only 1. Okay, so first understand what is a polynomial. Polynomial is any equation which contains like variable to the power constant something. So just a minute. So let's say I have written this expression x square plus x plus 2 is equals to 0. So this is a polynomial. Why? Because there is a power, there's a constant powered function used in the expression. So we have studied about functions in the class, relations in functions. So there were several type of functions. Let's say here e to the power x is involved. So this is an exponential function, right? Now this can't be polynomial because this is using an expression which is not polynomial in itself. So e to the power x is an exponential function because of which this is a mixed kind of function. This is not exactly an exponential function, or it can be anything, right? But this is certainly not polynomial. So if our equation uses anything like exponential function, logarithm, trigonometric functions, that is not a polynomial. Guys, remember this. Okay. So if the equation oh no, I'm sorry actually. Just a minute. Yeah, right. So we are talking about a differential equation, right? Yes. So if you're talking about differential equation, yes, exactly. So this is a polynomial. But if you're using derivative in the power of any other function, so what I'm trying to say is, let's say we have this equation. This is certainly a polynomial because we haven't used derivative anywhere in the in the other function, in the form of other function. But if let's say if I write, can I remove this? Have you guys written? Okay. So let's say I have some equations. Let's say I have these three equations, right? dy by dx plus e to the power dy by dx is equals to k. So, and what first had was the equation dy by dx plus e to the power x is equals to k, right? Or something like that is equals to x, right? So this is certainly a polynomial because right now, what is our variable is as a whole, dy by dx is a variable, right? So what we are searching for is that if dy by dx is used in the form of other function as it is used here, because it is we are using dy by dx in the form of exponential function, right? So this is right now an exponential equation, not a polynomial. So whenever we are using a derivative in the form of other functions, that equation will not be polynomial, and all other equations in which we are using our derivative. So let's say take second equation, dy by d2y by dx square plus cos x plus e to the power x is equals to log of dy by dx. So this equation is also not a polynomial, not a polynomial indeed, because we are using dy by dx in the form of log. In this case, this is more like logarithmic equation, or we can say mixed equation, right? But in this case, this is certainly not a polynomial in D because we are using dy by dx inside a logarithm function. So whenever we are using a derivative in the form of other functions, in all such cases, the equations will not be a polynomial. And hence, if the equation is not a polynomial, the point is this. If equation is not a polynomial, then degree is not defined. So if we take this equation, its order is 1 because we have used highest order 1. Right? Or let's say we have used here d2y by dx square. Then what is the order? Can you guys tell me now? dy by dx plus e to the power d2y by dx square is equals to k. What is the order of the equation? Degree is certainly not defined because this is not a polynomial. If the equation is not polynomial, in all such cases, degree can't be defined. But order can be defined every time. So if we have used dy by dx and d2y by dx square, both the derivatives, in this case, order is 2. Because we have highest order derivative used is 2, right? So degree is not defined and order is 2. Can you guys tell me, in this case, what is the order?
2.
Yes. And degree?
Not defined.
Third case?
Order is 3 and degree not defined.
Why degree is not defined? Because this is not
trigonometry.
Okay, trigonometric function, but we haven't used derivative inside a trigonometric function. We have used the general trigonometric function, but that doesn't matter. That doesn't change our polynomiality. That doesn't change the function of the equation, because we are checking differential equation. We are not checking a normal equation. So in normal equation, your variable is x and y, but in this case, differential equation, you're using a combination of dependent variable and independent variable together, right? You're basically using dy by dx. So your variable right now is dy by dx. You have to check if the equation is polynomial in dy by dx or not in x or y, right? So whenever in this case, see, your d3y by dx cube is used independently, right? In this case also, dy by dx to the whole power 4, it is used independently. There is no cos, there is no sine or logarithmic or exponential function which is used here, right? Exponential function is when this is used inside, like if I use 2 to the power dy by dx, this is an exponential function. Because we are using constant to the power variable, right? And what is the variable? Dy by dx, or any derivative. It can be any derivative, but the variable here will be considered as the whole derivative part. So if this equation is using cos x or sin x, log x, 2 to the power x, that is okay. In those cases, the differential equation is polynomial. The equation may not be a polynomial, but the differential equation is a polynomial. But in this case, third case, see, in the second part also, the equation was polynomial because of this and this. Differential equation, they didn't affect the differential equation, because we have only used cos x and e to the power x. But in this case, log of dy by dx, this derivative is used inside log, which is not okay for the polynomial equation. So this was degree not defined because of this part, Right? But in this case, degree is defined, and degree will be used in its exact definition. Now, what is the definition of degree? That it is the highest power of the highest order derivative. Now, in this case, we have used 2 powers, right? So we have d3y by dx cube to the whole power 1, right? And we have dy by dx to the whole power 4. So we'll use this power because this is the power of highest order derivative. So degree will be defined, if defined, which will be defined only if the differential equation is polynomial, right? So degree will be defined as the highest power of highest order derivative. So the highest order derivative in this case is 3, right? d3y by dx cube. And the highest power used is 1. So degree will be 1 only. Degree will not be 4. Now let's go through with some other examples. Tell me the degree of this. And order and degree both. Yes, guys. What's the order and what's the degree?
Order is 7 and degree is 2.
Okay. Is it correct? Z.
Yes.
Okay. So let's change this equation only to this. Now, what's the order and what's the degree?
So is that y dash?
Yes, y dash.
So degree order is same 7, but degree is changed to 1.
1. Okay. Will
Degree
degree be
not defined, sir.
Not defined.
Yes. Correct. Okay, let's change this only to this. For y. And this too. Now, what's the order and what's the degree? And sorry, let's change this as well. Yes. What's the order and what's the degree?
So order is 10 and degree is not defined.
Degree is still not defined, correct? What's the order and what's the degree?
So order is 10 and degree is 1. Degrees. So I'm little confused with degree.
How? So what do you think, according to you? I mean, what are the 2 values or 3 values which you're confused about?
So 3, 2, and 1.
So 3 is the power of d3y by dx cube, right?
Yes,
Third
yes.
order derivative.
I
So
think 1 is the degree
1,
because
very
the 10
well,
is the highest derivative.
correct.
That's what.
So what is it if we change it to this?
Then degree will be changed to 1. 7, 7, 7. Sorry.
Yes. Okay. Now let's find out one more case. So change the equation. Can I remove this? Yes.
Yes.
So this is cube root, guys. You know, na? Cube root. So you want to find out the order and degree of this equation, right? Give me 1 minute. You guys find this out. Sorry, I'm just changing this to the 4. Yeah, do it and just give me 1 minute. Yeah, I got to answer. Oh, so that is incorrect. Is it? Nazira, what's the answer? Can you tell me? Have you solved the question?
Yes, sir. Order is 3 and degree 4 by 3.
What's a degree 4 by 3? Okay. Can you guys tell me again what is a polynomial? Just quickly. See, this equation was polynomial, right? But is this equation a polynomial? Guys, the power of variable must be what?
Constant.
Whole number. Whole number, not constant only. It must be whole number, right? 0, 1, 2, 3, 4, 5, 6. Then only the equation is polynomial. Powers of variable are whole numbers. So this equation is not a polynomial, hence the degree is again not defined. The degrees are constant, but still only whole numbers are possible. So this is not a polynomial straight away because it is using power 1 by 2. So whenever the power is in fraction again, then the equation is not a polynomial. So it is 1 by 2 and it is 1 by 3 in fact. So you have to solve these equations. Now how can you solve power 1 by 2 and power 1 by 3? If
Can
you
we
had a
square on both
Okay.
sides?
Mhm.
Can we do square?
Yes, you can square, but if you square, the power 1 by 3 will not be solved. If you square, the power will be 2 by 3, right?
Yes.
So how do you change the fraction? Both the fractions simultaneously. If you take power 6, no, it will also be used. I mean, it will also be solved. Power 1 by 2 and power 1 by 3. So let's take power 6, both sides. So this will be d2y by dx square whole cube plus 2 to the whole power 3. And this will be 1 plus d3y by dx cube to the whole power 4. Power 4 whole square, right? So if you take power 6, this will become cube and this will be the square. Now if I solve it, I'll get the equation which will be polynomial. Right? I don't need to solve it. I can tell the power from here only. So the power order will be 3 because order can't change. Once it is defined, this can't change. But degree in this case will be what? Now you guys can tell me the degree.
6.
Rather 8. No. This is power 4. So this will be square of it. 4 to the, I mean, not 6, right? This will be y3
Yes, sir.
dash.
Yes, sir.
Yeah. So the degree will be 8. Just remember this question. And write this. Can I remove it, please? Yes. So this is one part where we have to understand what is a differential equation, right? Now let's understand one more type. This will come handy because we will have to learn about this type. So these are linear differential. Let's talk about linear. So let's say this is an equation. This is a very simple equation, right? The main part of the chapter will be to solve a differential equation. But before that, we have to understand some things. And let's understand those things through this example. So we have considered this differential equation, dy by dx is equals to x. Now, how can I solve a differential equation? The main part is to solve the differential equation. You have to separate this dy and dx, right? So how can you separate here? You can multiply dx to the right hand side. This will become dy is equals to x dx, right? Now you can integrate both sides. If you integrate both sides, this will look like dy is equals to x dx, right? Now what is the integration of dy is? Basically,
So
this is 1. Yes, 1 into dy. So integration of 1 with respect to dy will be y. And what is the differentiation of x with respect to dx?
X square by 2.
Plus c, right? Because we used c with indefinite integration, right? So here we have this plus c while integrating x with respect to dx. So x square by 2 plus c. This is the equation of this differential equation. Now, if you differentiate this whole equation with respect to x, you will get dy by dx is equals to x. Let's differentiate it once. So if we differentiate it with respect to x, this will become dy by dx, right? This x square 1 by 2 will be 1 by 2. X square will become 2x plus c plus 0, right? Differentiate with respect to. So if we have a differential equation, we can get its solution. And if we have this equation, any equation, we can form another differential equation. Okay? So dy by dx is equals to 1 by 2 into 2x will become dy by dx is equals to x only, again, which was the original differential equation. Right? So that is how the process will work, first of all. But before this, in some cases, we have to verify that whether the given equation is a solution of the given differential equation. Let's take some examples from exercise 9.2. We have to verify some of the solutions to the given differential equation. Now, how can we verify? We have two methods to verify. Either we can go from differential equation to the solution, or we can go from the solution to the differential equation. Now, the easiest part will be to go from the equation to the differential equation. So we have been provided in the first question, this equation is y is equals to e to the power x plus 1. And the differential equation is y double dash minus y dash is equals to 0. Now we can find y dash and y double dash, and we can compare that they both must be equal. In that case, we will get y double dash minus y dash is equals to 0. So we can find out y dash, which is dy by dx only. If we differentiate this equation with respect to x, we'll get dy by dx is equals to differentiation of e to the power x is again e to the power x plus 1 is plus 0, right? So dy by dx, which is y dash, is e to the power x. Now if we again differentiate it, we'll get d2y by dx square, right? And we will get e to the power x again, because the differentiation of e to the power x is e to the power x. Let's name these equations as first and second. So if we use that in the given differential equation, y double dash, given differential equation is y double dash minus y dash is equals to 0. We have y double dash as e to the power x minus y dash as e to the power x, which is 0. So this is the easiest method through which you can verify your given solution as the solution of differential equation, right? Because see, if you go from differential equation, you may not be able to solve every differential equation which is given, because in your course, we'll only learn about how to solve first order and first degree differential equations. Because second order and higher degrees equations will be complex to solve. So in this course, you will be only learning these very basic differential equations, which are first order and first degree. Now there will be three types of differential equations, right? We'll learn how to solve them, but before that, we have to two exercises, right? 9.2 and 9.3. In the first exercise, we will have to prove which is the easier exercise among the two. But this part, right? Let's solve one more question to understand it better. But this is the part which you'll be comfortable with. So let's solve this seventh question. XY is page number 385 page. Question number 7. XY is equals to log y plus c. Now the c is a constant, obviously. We haven't defined it, but c is a constant. You have to prove this is a solution. Is this a solution? You have to check, verify that is this a solution of this differential equation? Y dash is equals to y square upon 1 minus xy. And xy is not equal to 1. So these are actually known as the end conditions, but we'll talk about them whenever required. In this question, it is not much required about. This is basically given that if xy is 1, then the denominator part is 0. So this is a redundant information. But we will have to use these informations in some question. We will be explicitly told about this. So let's check whether this is a solution for the given equation or not. See, there is only one derivative involved, right? Y dash in the given equation. So you just need to differentiate it once and put in the given equation. Yeah. Someone has completed. What is y dash coming out here? So let's say if we differentiate xy, right? Xy, we have two functions, x and y. Two different variables. So you have to apply product rule. We are differentiating with respect to x. So let's first differentiate x. x with respect to x is 1, then y is as it is, plus x as it is, y with respect to x will be dy by dx is equals to, then log y will be 1 upon y into differentiation of y will be dy by dx plus differentiation of constant will be 0, right? We can take this x into dy by dx towards the right hand side. We'll have, or we can take y and 1 upon y dy by dx, we can interchange them. So we'll get x dy by dx, or we can write it as xy dash minus 1 upon y dash is equals to minus y, right? So take y dash common, this will be x minus 1 by y is equals to minus y. You can take y as LCM, so it will be 1 into y, yx and xy minus 1 is equals to minus y. Y dash is equals to minus y square upon xy minus 1. Correct, Hadia. So we can take this minus in the denominator. This will be y square upon 1 minus xy, which is the given differential equation. So this will be the easier part. The only thing you need to know about this is that what is the connection between a differential equation and the given equation, right? So let's say if we have used one constant, so you have to know about the arbitrary constant involved in the given differential in the given equation. The number of arbitrary constants in the given equation will be the order of your differential equation. So what is an arbitrary constant which is not known, right? So let's say we have this equation y is equals to e to the power x plus 1. In this we have constant, but we know the constant. The value of the constant is 1. But in this case, xy is equals to log y plus c. C is a constant which is unknown. So all the unknown constants are arbitrary constants. They are constant, but we have to eliminate them to form a differential equation, which will be the thing we'll be doing in the next exercise, which will be the topic for the next exercise. So we have to remove these unknown constants, basically arbitrary constants, to form a differential equation. So in all such cases, when you are given these arbitrary constants, you'll be asked about the order of the differential equation. So let's say if I ask about the order of this differential equation, in this case, the order will be 1. And you can see that in the given differential equation. This is the differential equation of xy is equals to log y plus c, in which the order is 1. So whatever is the number of arbitrary constants involved in the given equation will be your order for its corresponding differential equation. In this case, the order is 1, and as is the number of arbitrary constants. So the only thing you need to know about here is the number of arbitrary constants will be the order of its corresponding degree. So guys, this is simple, right? You can always tell the order. Let's tell me the order of this differential equation first. Y is equals to mx plus c. Which type of curve will form if we write y is equals to mx plus c?
So straight line like y equal to
Correct. Yes, correct. Straight line. Now, what's the order of this differential equation? If we form a differential equation from this, what's the order?
so 1.
1y,
So there is only one arbitrary constant as c.
which is the arbitrary constant here?
I think c.
C. Okay. What is m then?
M is a variable.
M is a variable. No, y and x are variable, m and c both are constant. So other than y and x, all are everything is constant. Sometimes we can use z or t to use another variable, but most of the times, whatever variable, whatever alphabet is used in the equation will be constant only. So y and x are your basic variables, right? M and c both are constant here. So we have two constant, right? So the order should be what?
2.
2 in this case, because we have to eliminate these two constants to form its differential equation, right? Let's solve some more question. Can I remove this?
Yes.
If someone is writing, you can just raise your hand. Yeah, cool. So we can always know the order of a differential equation if we can correctly identify how many number of arbitrary constants are involved. Just find the order of the given differential equation. The first equation was y is equals to mx plus c. So we know there are two constants. And hence order is 2. What is the order of this? Mx plus c. Obviously, y and x will be the variable only. Plus d. Y is equals to mx plus c plus d.
So 3.
Okay. This seems like 3, first of all. The c and d are very, constants only, arbitrary constants only. But c plus d will obviously be a constant, right? So I can write c plus d as e. So whenever we can reduce the constants, what is an arbitrary constant? Arbitrary constant is something that has a value, but we don't know the value. So c and d both do have a value, but c plus d will be a constant only. We can eliminate c plus d. We are redundantly using one alphabet here. Either we can use c or we can use any other variable to show that c plus d will be a constant only. So in this case, we only have two variables. Y is equals to mx plus e, which can be, c plus d can be termed as another variable. So the order is 2 only. So it's not like how many alphabets I have written. It is the number of alphabets which must be needed to form the equation. Right? If you can eliminate the variable, then you're good to go. So just try to eliminate all the possible variables. How many, as many as you can. So after that, you will identify that how many numbers of arbitrary constants are present. Let's solve this one. Ay is equals to bx plus c. Obviously, only y and x are variable. Ay is equals to bx plus c.
So 3.
You can try to reduce the number of constants. Maybe there is a way to reduce the constants. Okay, let's understand one thing. In the first example, we have an equation y is equals to mx plus c, which represents what? A straight line, right? In the second equation also, when I write y is equals to mx plus c plus d, this is a constant only, right? So this equation represents straight line only. Hence the order must be 2 only. Order can't change if the curve is not changing. Order is basically defining your curve. So if the equation is straight line, the order is 2. That we have already proved in first and second part, right? Now, what is this third equation? This is ay is equals to bx plus c. Again, a kind of straight line only. We're just representing the equation of straight line in different fancy forms. So ay is equals to bx plus c is a straight line only. In that case, the order must be 2. But if you see here, we have used 3 constant to define this. Can we reduce We must reduce because the order is 2 only. But how can we reduce that?
By dividing the whole equation by A.
By dividing the whole equation by A. Good. Or by dividing the whole equation by C. Or by dividing the whole equation by B. You can do anything. Right? Because see, if you have to reduce one variable. You can reduce any of them, right? I mean, one constant. So if you divide the whole equation by A, it will be y is equals to b by a x plus c by a. And again, b by a and c by a, again constants. So they can be termed as d and d. This will be dx plus e. So the order is 2. So just remember this. Then there are some equations in which you may be provided with the redundant arbitrary constants. You have to reduce them. One basic rule is like if you see any kind of constant, any kind of alphabet with y and x, you just have to divide the whole equation by that variable. That way you can reach to the closest. Now the next part involves formation of a differential equation. So whenever your general solution is given, sorry, we haven't talked about general solution, so let's stay away from that first. So if you're given an equation, you will have to form a differential equation of that equation, right? So what is a differential equation of the given equation? First, understand this. So let's say I have y is equals to e to the power x plus c. Now I told you that the number of arbitrary constants involved in the given equation is the order of the given equation, right? So the number of constants in this case is 1. The c is the only constant, right? So the order of this differential equation must be 1. So now how did we define that? How did that rule come into the picture? So to define a differential equation, we have to eliminate all the arbitrary constants. The differential equation should not have any arbitrary constant involved. So let's say if we have y is equals to e to the power x plus c, we have to remove this c using differentiation, right? And how can we do that? We just have to differentiate this whole equation with respect to x. So this will become y dash is equals to e to the power x. Right? This is the differential equation of the given equation because we have removed c. Right? Now to remove that, to remove one variable, you have to use one derivative. So that is how, if you have two variables, you have to use differentiation twice because you have to remove two variables now. If you have 6 variables, you have to remove 6 variables. In that case, you have to differentiate the equation 6 times. But all the variables must be arbitrary constants. That is, they must be required to represent the equation. If there is a redundant variable which have no use in the given equation, you have to eliminate that beforehand. Right? So this will be the corresponding d. Corresponding d, right? Y dash is equals to e to the power x. Now how to, let's say we have this y is equals to mx plus c. Now we know there are two arbitrary constants. Now how do we form its corresponding d? So we have to eliminate m and c from the given equation by using differentiation. So we will first differentiate the whole equation with respect to x. This will become y dash is equals to mx will be m only plus 0. But we have to differentiate it twice. Right? So in that case, we'll differentiate it again. Y double dash is equals to 0. So that is the corresponding d. Because the order must be twice. As soon as you reached your second order, this is your corresponding differential equation. Because you are not using m and c, to define the equation, or not using the original arbitrary constant to define the differential equation. you should not use your original arbitrary constant. Basically, to form a differential equation, you have to eliminate all of the arbitrary constants. Now, this looks like an easy process, but this is not. The first two exercises are very simple. You would be good to go. If you have any doubt, please ask me. We'll solve it like within minutes. You'll understand the doubts, no problem. But this exercise, third exercise, will give you some problems. So will put you in some trouble because there'll be questions which will be related to the direct curves. So you must know the equation of curves first of all. And after that, the process of elimination is also not that easy. Now, to give you some idea about it, let's solve this question. Let's solve it together, right? You also have to solve it. Can I remove this? If someone is writing, just tell me.
Sir,
Yes, Hadya.
sir, the third exercise is deleted for us.
Okay, third is deleted for you guys.
Yeah.
Are you sure about it? Can someone else confirm it? Anyone? Nazia, Sakina, Zaid. What about you guys? Do you know about this?
I'll check, sir.
Okay. In that case, it's an easy task. In that case, we can proceed with the methods of solving. Because you have to either solve that process. But let's
Yes, sir.
understand for this is deleted, Nazia.
Yes, sir.
Okay, good. Cool. In that case, we should move on to the methods of solving, right? This is an interesting part. So we have basically gathered the all the information related to D. Anyway, this was the boring part, guys. I'm so happy that it got deleted. It wasn't required. I don't know why they were teaching this. It wasn't required to teach you. So yeah, let's delete the process. So let's correctly come to the, they have done this great job. So let's correctly come to the part of method of solving. So you have got a basic idea about a differential equation. If you check for any differential equation, there must be a derivative present, right? Then there will be there will be an order and degree. Degree may or may not be right associated to a differential equation, right? Order will be the highest times you have differentiated a dependent variable with respect to independent variable, right? And the degree will be if the equation is polynomial. Now, the variable of the equation is dy by dx or any derivative, not y and x, not just y and x. No, the power of the all the derivatives, right, must be whole number first of all, and the derivative must not be present in the form of another function. Like you can't have cos y dash, cos of dy by dx, or you can't have e to the power dy by dx, right? So whenever the equations of dy by dx is equals to something, or d2y by dx square plus dy by dx, any equation which contains your normal dy by dx y dash and y double dash, not in the form of any other function, and the powers must be whole number, will be given these kind of equations only, right? Which I'm talking about, that simple equations which involves your derivatives, right? And the derivatives will be mostly the derivatives will be in the form of a polynomial only, right? Or if there is not, you will just need to only ask about order and degree. You need not to solve any such equation, because these are complex differential equations. So you got a basic idea about differential equation, that there is an order and there may or may not be a degree associated with the D, right? And what is the general and particular solution of D? Let's talk about this. So differential equation, right? So let's say this, we know its differential equation is y is equals to x square by 2 plus c, right? I mean, if this is the differential equation, this is its solution. Or for this equation, the corresponding differential equation is this, right? So any equation which correctly satisfies your given DE is known as the solution of the DE. Now the solution can exist in two types. So let's say this is the solution, y is equals to x square plus 2, x square by 2 plus c. So this is a general solution. Why general? Because c can take many values, c can take infinite values, right? So all the equations, yeah, all the solutions in which arbitrary constants are involved, all the solutions in which arbitrary constants are involved, that is unknown constants are involved, are known as general solution. And all the solutions, let's write this general solution. And all the solutions in which the value of constant is known. All the solutions in which the value of constant is known. Is known as, or are known as, particular solution. I'll show you the example in this case only. So let's say you know the value for C. I mean, there are many values of C possible. So this is a family of curve. But if I take, let's say, the value for C as 1. So this is y is equals to x square by 2 plus 1. So this is a particular solution for this differential equation. This is general solution. And this is a particular solution. So particular solution is in which there is no unknown constant involved. And if you use these arbitrary constants, in that case, the solution will be known as general solution. Now we have to reach to this either general solution or particular solution. Particular solution we can only reach if there are some information about the function is already given, right? But if there is no information given about the function, we can reach to general solution. So we'll be given the differential equation, we have to reach to the general solution. This is known as method of solving of a differential equation. So we'll be learning about methods of solving a DE. Now, what kind of a DE? First order and first degree. Method of solving a first order and first degree DE. That is exactly what we'll be learning. So first order and first degree DE. There are, however, we have like 8 types of first order and first degree differential equations. But in our course, we'll be only learning about 3 types of first order and first degree differential equations. So these 3 types are, now they are easy to learn, okay, but you have to understand the process with the differential equation. So you'll have to first understand what kind of differential equations these 3 are. If you understand them, then you'll understand the method of solving them. Method of solving first order and first degree differential equation. So we have first is variable separable. Variable separable. The second one is homogeneous. Their order may be changed. And the third one is linear differential equation. So you have to understand all of them, and if you understand them, we'll be able to solve them. Correct. So the important part is what are these kind of differential equations are.